All right, this is where we left off yesterday. We were talking about Lewis dot structures. We talked about how for this guy here, we need a double bond to make this work. That way we can end up with our 12 electrons, 2, 4, 6, 8, 10, 12. We need to make sure that carbon has 8, 2, 4, 6, 8. And we need to make sure that oxygen has 8, 2, 4, 6, 8. Hydrogen's perfectly satisfied with just 2. That's all it needs, okay? And that's why hydrogen has to always be at the end, or they call that terminal. Terminal means the end, okay? So if you have terminal cancer, not good. If you are going to an airport, you go to an airport to get to your airplane, okay? Because that's the end of the airport. You get to the terminal. That's where the airport ends. It terminates, and you get on the airport and go. Okay. Yeah. It is. Well, I mean, you know, sometimes terminals are good, like if you want to go on an airplane, but other times terminals not so good. For hydrogen, terminal for hydrogen just means it's on the end. So, okay. Here are some exceptions. So, exception number 1. Well, exception number 1 really was hydrogen, okay, because it gets 2. Exception number 2 is these elements that can have what's called expanded octets. So the non-metals starting in period 3, okay, so that is your silicon, all the way up to argon really doesn't do anything. So silicon, phosphorus, sulfur, chlorine, and then arsenic all the way to krypton. And yeah, krypton can bond with some stuff. I know you're like, whoa, mind blown. Yeah, it can. It's weird. Xenon, the next one would be antimony through xenon, bismuth through radon. Well, I don't know about radon, but they're not going to give you that anyway. But anyway, those you can expand the octets. So they can accept more than 8 valence electrons. So for example, this sulfur here has 2, 4, 6, 8, 10, 12. Okay. And the reason it can do that is because it can expand into, here's my periodic table. It can expand into this D block. Because remember, right here, what level is this stuff in right here? 3. Okay. So these are in the 3 as well. So they can expand and bond into this D level. Okay. So when we look at this guy, for our first exception here, okay, when that happens, the expanded element has to be the central element. Okay, so if this was like chlorine out here, it wouldn't expand. It has to be a central element here in order for it to expand. How do we figure out what goes in the center? Lower electronegativity. And typically, they are going to throw you a bone by giving you the formula for this. And remember that formula is most often given to you in order of electronegativity, with the least electronegative element being in the front. So whatever that front element is, most of the time, that's going to be your central atom. Okay? Not all the time, like for example, this guy. Okay? Hydrogen's not going to be your central atom. Why?
Terminal.
Because it's terminal. Okay? But typically, in something like this, they're going to give you a hint by showing you a formula, and that's usually going to be your central atom. Okay? I'm not going to say all the time, but a lot of the time. All right. Do I talk? Did I skip over boron?
There's no boron. Yeah. Oh, no, it's the next slide. I don't know where that.
Is it on your, do you have anything in there about boron?
It says boron has incomplete octet.
Yeah, but I don't have a slide. It's not on my slides.
Yeah, but 6A5A.
Oh. Okay. So boron has an incomplete octet. It ends up being happy or satisfied with 6 electrons. So this, if we have boron trifluoride, this is what that would look like. Your boron would be here. It's going to be happy with 6 valence electrons. So 2, 4, 6. Boron's another exception. Okay. We can make up the octet by forming bonds with other compounds with non-bonding pairs of electrons, like ammonia. So NH3, and that should be a lowercase. Sorry about that. So nitrogen, and then we would have our hydrogens down here, and we would have our lone pair of electrons here. New shared covalent bond is made up by using both electrons from one species, and those are called CC bonds or coordinate covalent bonds. Okay, so if I were, let's see here, if I were to draw this guy here, so if I were to draw this guy, my carbon would bring 4 electrons to the table, right? My oxygen would be bringing how many? 6. Okay. One of them is going to hook up right here. Does that make sense? Okay. Then I'm going to erase that line and I'm going to replace it with a line just to make that easier. And that line I'm going to do purple and orange to show you where each of those electrons came from. Everybody cool with that so far? All right. I need to get a full octet here and a full octet here. It's not working out the way it's written. What do I got to do next? Yep, so I'm going to take an electron here and bring it in. And I'm going to bring in electron from here as well. There's a little darker. And then I'm going to get, oh, shoot, I got carried away there. Okay, there we go. It came back. All right, so now this is where we're sitting. So oxygen's okay right now, 2, 4, 6, 8. Carbon, though, 2, 4, 5, 6. Carbon needs how many? 8. We have to have these in pairs. So I'm going to take this guy over here, and I am going to bring him over here so that he's a lone pair. Instead of hanging out by themselves, they need to be in pairs. All right, so I've done that. Am I done? No. I can't take this guy and bring him in here because that's not going to solve anything. But what I can do is I can take these 2 electrons here and bring them into the center. But where are those coming from? Those are both coming from the oxygen, right? See that? Did you see how I pulled those electrons over? Yes? Jade? Okay. So since these 2 electrons came from the oxygen and none from the carbon, these are called a coordinate covalent bond or a CC bond. Now if I do my element count, 2, 4, 6, 8, oxygen's good, and carbon, 2, 4, 6, 8, it's good as well. Okay, makes sense? Everybody cool with that? All right, so let's see if we can draw this. What's going to be in the center?
Carbon.
Carbon. Okay. We also need to count up how many electrons we've got here. So carbon, I've got 2 of them, times 4 is going to give me 8. 3 times 1 is going to give me 3, and then 7 here. So that's going to be a total of 18 electrons. Anybody not know where I got 18 from? Talk to me now. Don't be afraid. Yay or nay? Okay. All right, so now I'm going to start building my structure. I know carbon's going to go in the center. I'm going to connect it to another carbon. I'm going to connect a hydrogen here. I'm going to connect one here. I'm going to connect one here, and then I'm going to connect my chlorine here. How many? What, honey? I try to make it as symmetrical as possible. So if I drew it like this, it wouldn't be very symmetrical. And nature likes symmetry. So I also, part of this is the more you draw these, the more you know how they're going to come together. And it just takes practice. And so I already, just from having drawn these so much, I already know kind of in my mind that that's going to have to be how it works. So I think that's part of it. Like the more practice you get with these, but honest to God, like that's why there's so many of these for you to draw over the next few weeks. Like you just have to go and do it. And then eventually it's going to be like riding a bike and it's easy. But until you get over that like curve of getting used to it, it's going to be a little painful.
Is there only like one way to draw one compound?
Okay, so right now where you're at with what you're working with, the answer is no. I'm going to be teaching you more steps along the way. There's something called formal charge that's going to get introduced, I believe, tomorrow. And that's going to answer a lot of those questions. So for tonight, you might have some structures that look different than mine. For those who had me for pre-AP last year and the year before, you've heard of formal charge before. And you know that that's the answer to this whole question that you brought up. For those of you who were lucky enough not to have me, okay, you may have not heard of formal charge yet, and you've got to wait until you get to that point. Should minus has. That's the key, okay, if you want to think back on it. Okay, so I don't know if that answered your question or not, but okay, so now we're going to go through and we're going to check how many electrons. How many electrons do I have in this structure? 2, 4, 6, 8, 10. Okay, I need 18. So the next step is to go and place my lone pairs of electrons around everything that needs it. Okay, so I've got 2, 4, 6, 8, 10, 12, 14, 16. I'm still not there.
Did you make that a double bond one?
Exactly. Yep. So we're going to make a double bond between these 2 carbons. Okay? Because each one would have had an electron in each one. If we make a double bond, now we've got it taken care of. I believe we're up to 18 electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18. And then go back to your chlorine. Make sure it has 8. Go back to each of these carbons and make sure that they have 8. And if they do, then you're good. And again, these are going to take practice. My answer key is going to be up there. You're going to be able to look at it. You can Google these too. I could bet that most of the things that are on here, you probably even find a video of somebody showing you how to do them. Okay, but you're going to have to take the extra time to spend going out and doing some of that work. Okay, honestly, I can sit here and I can show you how to do every one, but you're gonna have to practice. That's just all there is to it. It's just like band or orchestra or anything like that. You've got to just practice. Or sports. whatever you want to think of your analogy for. All right, so spend a minute or two drawing these guys. See if you can get that. Now this one has a negative charge on it, so maybe we should do one of those so I can show you. I'll do B with you, and then I'll cut you loose to try some of these. Okay? I'll give you a couple hints along the way too. So this one, we've got our oxygen, and we've got it bonded to hydrogen. Okay? How many electrons? I've got 6. I've got 7. And what does this negative charge mean here? 1 more. So I would normally have 7. Now I have 8. Okay? And there's my 8. And I have to indicate this negative charge. I draw a bracket around the whole thing and put the negative up here. If it was a -2 charge, I'd write -2. If it was a -3 charge, I'd write a -3. It had a negative charge on it. See that?
So where does the extra electron go?
Wherever you want it to go. So if we had our oxygen here, if I draw these in different colors, oxygen would look like this. My hydrogen would look like this. And then I have an extra electron floating out here. Okay? So I can take this one and I can bond them together. Okay? And then I can take that extra electron over to here, and then that takes care of that octet. And then I have to draw my brackets around to show that it has a negative charge. All right. Now on this one, remember boron's special. And on this one, sulfur can have an expanded octet. So see if you can figure those out with some of those hints that I just gave you. Sometimes when I'm struggling with these, I will take different colors, or I'll represent my electrons with dots and circles or something like that. And sometimes that helps me too. Oh, yeah, you can come in during, yeah, you were trying to skip English. That's what you were trying to do. I remember now.
Me?
Yeah.
Yeah. What? I totally could have, because we didn't start for 11 to 8. Yeah.
Did that one. 4, 14, 6, 24. What's wrong, honey?
I said I remember the rest of these.
Mm-hmm.
Right now, it doesn't matter if it's gonna look like in a different way. Just like we didn't put the sulfur on the bottom.
No, that's fine. And that wouldn't matter anyway. That's not going to make any difference any which way when we get into these. That's just personal preference. As far as I know. Now, when y'all get up into advanced chemistry, you may be cussing me at some point. I don't know. I'm trying to do as best as I can with y'all, but, you know. As far as I know, it's just personal preference. let's see where we're at with electrons here. 24, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24 if I do that. Let's see if that takes care of that guy. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so we're good there. And actually, when you draw this, when we get into it, remember we've got shapes that we're going to be learning. And then you'll have shapes to include with this too. But for right now.
Can all elements form a double bond?
No. No. Like fluorine cannot. Because fluorine only has one spot that it can accept an electron, and it can't expand its octet. So there's fluorine cannot do that. Nitrogen can, carbon of course can.
So anything that has 6 or less electrons in its valence shell? Or
Yeah, those should all be able to.
and something like lithium double bond?
Well, lithium's a metal. So lithium typically will end up being part of a ionic bond because of its low electronegativity. So it'll either be a metallic bond with another metal, or it's going to be an ionic bond. So it doesn't share electrons. So then we don't double, triple, we don't. These are just covalent bonds. So these are typically non-metal situations.
So only in the people.
And hydrogen.
And hydrogen can double bond.
Well, no, but I mean, as far as covalent bonds,
Yeah.
no, hydrogen cannot double bond. No. Sorry. I just meant as far as covalent bonding is concerned. Hydrogen would but primarily most of the time, your covalent bonds is going to be in the P block, or at least the nonmetals in the P block, and then hydrogen. Okay, and then your chlorine is going to go here. All right. And then I'm going to do this guy down here because I ran out of room. 1, 2, 3, 4, 5, 6. Chlorine, 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 chlorine. 6 times 7 is 42. So this is 48 electrons here. 1, 2, 3, 4, 6. All right. That work for you? That's it. So I believe I saddled you with some homework tonight, right? And it's not just that you do. I think I gave you another worksheet on top of that, didn't I? Okay. So, yep. So you've got 2.5 and 2.5a. So I'm giving you time now to work on some of that. So that'll give you some time with it. I will post your answer keys as soon as the video posts. You've got until 37. So I give you 7 minutes in class to work on your homework. That's pretty good, right?
7?
7. 11:37 is when the bell is supposed to ring. So. I'm just so generous.
For expanded octets, does it have to have, can it just be over any number over 8?